In this video, we will compute a double integral of a function of two variables over a rectangular region of the plane. So here we're given a function to integrate, and the domain of integration is the rectangle R, which goes from 0 to 1 in the x direction, and from 1 to 3 in the y direction. Now by Fubini's theorem, since we're integrating over a rectangle, we can integrate in either order we like. That is, we can first integrate with respect to x and then y, or we can first integrate with respect to y and then x. And we should get the same answer both ways. So it's sort of an important skill to be able to decide which order to do, because sometimes one way is easier than the other. Now if we look at this example, we want to decide if we want to integrate first with respect to x or y. And here we'll do y first. The reason being, if we look at the integrand as a function of y, and think of x as just being a constant, then the function looks like 1 over 1 plus y, which we know how to integrate. We'll just get a logarithm. But on the other hand, if we integrate first with respect to x and think of y as a constant, then we'll have to integrate x over 1 plus x, which is doable but slightly harder. So we'll decide to do it in this order. So first, we'll integrate with respect to y and then x. So we would put the bounds like this. The first integral is on the inside and the second one is on the outside. Okay. Now to make this slightly easier, let's do a U-Substitution just in the y variable. So x will still be from 0 to 1. But we're going to substitute here. I'll put my U-Substitution over in this little bubble. Let's have u be 1 plus xy. Then du, remember I'm thinking of y as being the variable here, is x times dy. So here's my du, and here it is right here. I have x dy, so that will just become du. And u is 1 plus xy, that's exactly the denominator. So once we do our substitution, this just looks like 1 over u du. And we have to change the bounds, of course. When y equals 1, u equals 1 plus x times 1, so 1 plus x. And when y equals 3, u equals 1 plus 3x. Okay. Now we do the first integral. Integral of 1 over u is just logarithm of u. We have to evaluate that from 1 plus x to 1 plus 3x. So we get log of 1 plus 3x minus log of 1 plus x. Okay, so we're halfway there. We've done the first integral, now we have to do the second. Now we have to integrate with respect to x. So let's take a little detour and remind ourselves off to the side here how to integrate the logarithm function. So remember, the trick here is to use integration by parts. We'll call log of x u and dx dv. and we'll use the integration by parts formula. So remember, it's uv, so log x times, and v is just x, minus the integral of v du. So v is x, and du is 1 over x dx. But x over x is just 1. And the integral of 1 is, of course, just x, and if we factor this out, it's x times log x minus 1. So that's the antiderivative of log x, is x times log x minus 1. Now we have to do this twice. Once for each term. So, first, to integrate log of 1 plus 3x, it's going to be, well, let's do some substitutions. Let's call 1 plus 3x v, and 1 plus x w. Then this is integral of log v times 1/3 dv because of the 3x, minus integral of log w dw. But the bounds have to change, of course. When x equals 0, v equals 1, and when x equals 1, v equals 4. Now when x equals 0, w equals 1, and when x equals 1, w equals 2. Now we use our formula in red over on the right. So the integral of logarithm is v times log v minus 1. This whole thing we have to evaluate from 1 to 4, minus, same thing for w. W times log w minus 1 from 1 to 2. Okay, first we plug in 4. So we get 4 times log 4 minus 1 minus, and now we do the same thing for 1. But let's see what we get when we plug in 1. We get 1 times log of 1 minus 1. Log of 1 is 0, so this whole thing is just minus 1. And if we subtract minus 1, that's the same thing as just adding 1. Okay, now the second term. We plug in 2, it's 2 times log 2 minus 1. And again, same thing as before. When we plug in 1, we just get negative 1. And now let's just distribute everything out. So we get 4/3 log of 4. And here we have, let's keep the parentheses, minus 4 plus 1, so minus 3. Minus, now if we distribute, we have 2 log 2 minus 2, but then plus 1, so just minus 1. Oh, since I put the parentheses back, that should be a 1, not a 4. The 4 should be inside the parentheses. Okay, now distribute one last time. Now we have 4/3 log 4 from this term. And now let's write this term. Minus 2 log 2. And now let's do these two terms. So minus 3/3 is minus 1. Minus negative 1 is plus 1. So those actually cancel. So the blue terms don't actually show up. And so now we're actually done. This is our answer.